This is a talk about, I guess, experiences and just trying to implement Active Directory features, trying to make them faster, trying to make them better. This is Wellington here. I thought it'd be appropriate given I've travelled this far. Got to show it off. So this is where we work. So first question is, what have we actually done in the last year? And there's actually a lot of things, and you could go through the release notes, which I've pretty much done. 4.9, lots of auditing, a new backend, password policies, backup, DNS stuff. There's trust stuff that Met's implemented. 4.10, there was a GPO import export, pre-fork changes to the process model to introduce more parallelism in the Active Directory server. We made changes for page searches. We added Python 3 support. We did more audit logging. But yeah, one of the things I'd really like to talk about is just how much of a difference we've made in the last few versions from 4.5 to pretty much where we're at right now. And so that top line is that's a log scale, and so it's dropped almost 100 times. There's almost 100 times difference in how long it takes for a DC to join, and that scale was maybe tens of thousands or something like that, but it probably gets worse. So over 100 times if we're talking larger DCs, so we've continued to make improvements over the last few versions, and this is sort of where master is currently at. So modified performance, similar story. It's not on a log scale, so I can't say it's 100 times or quite nearly so different. But there's a lot of improvements there. We made a lot of improvements in 4.7 and 4.8, and in the new versions we've dropped it even further. Although there's some inconsistencies in how we've measured it, and we've got some time gaps and things like that. But generally everything's dropped from when we started to where we are right now. And the last one is search performance, which is again same sort of story. Everything's dropped quite significantly. We had one particular case, it seems, that got worse, and it seems to be related to the locking. So when we introduced some more safety around the database locking, we actually made the performance worse. And yeah, I've got patches to fix that. That guy to go back down below that one, but still a work in progress. So the story is for 4.10 to 4.11 is basically performance, and it's almost entirely about performance. So there's replication improvements. So the join, as I've talked about, was 100 times better at not even that larger scale. Our linked attribute performance is significantly better, and it's still a cause of massive problems in our domains, but it's a lot better than where it was before. Rename performance, it's you can rename a quite a large OU and not take days. Now it's hours. Well, we're hoping, but yeah. So there's definitely things we could do there, but yeah, we've improved a lot of things in terms of the large scale to make sure that they work. Maybe they don't work quite as fast as we'd like, but they definitely work. So one of the ways that we've actually been trying to figure out whether or not we've actually improved anything is using our traffic replay runner. And we wrote this a few versions ago, but actually we haven't really been using it that much. It's only been in this last year or so that we've actually really tried to push using this. And basically how you replay the traffic is we take a network trace, you get a PCAP output, you then run a script on top of it. I think it's a Perl script that summarizes the traffic, takes out all of the the identifiable details about sort of the machines and things like that, and then sort of gets most of the main protocol details that it can choose to replay later. So using that, we can build a model for how we generate, we can build a model to generate new traffic, which is similar to this traffic. And then we can choose to play the traffic either using a summarized file or from a statistical model file. And then after that, we can analyze the results. And we get things like successes, failures, means, median maxes, and 95th percentiles. And so, you know, we run it against a reasonably large DC, and, you know, that's it, right? We're fast. 100,000 users, no problems, right? Like, you know, we don't do anything too intensive, and, you know, it doesn't look that bad. I mean, what's wrong? I couldn't really see anything that wrong at that point. And so I have some naive results. I mean, the operations here, that they're not that impressive. LDAP isn't that impressive, frankly, but it's just using constrained resources and things like that. So in 4.6, we got, you know, about 100 and something. 4.7, we actually managed to make it worse because we didn't realize that making multi-process can make things worse. So 4.8, we changed the way we did multi-process. 4.9, it's basically the same. 4.10, it's basically the same story there. Get master is probably slightly better, but it doesn't actually seem that much change, to be honest. Like, the traffic sample was largely DNS, name resolution, LDAP bind, and net logon. And so, you know, what's this backing up about? Like, how does this fit into our story? And so over the last year, we implemented domain backup, a new method of backing up an AD domain in Samba 4.9 and 4.10. And so why do we actually implement it? It's the existing Samba backup scripts had they had a bunch of problems. With a running DC, it wasn't actually safe. It was safer than some other things, but, you know, it wasn't that great. And so what we wanted to do was actually try to create a single source of truth from the domain data, and you know, using replication and things like that to have a sort of pristine backup that we can just seed a new domain so that it wouldn't have any conflicts with any existing data, and we can avoid versioning problems and things like that, and, you know, force users to actually try to have a consistent replica after they've reinstated their domain. So the basic gist of it is you sort of have an existing network. So you have your DCs, you run the Samba tool domain backup online, offline. Offline takes a direct database copy. Offline takes a direct database copy and locks it in the right ways. Online takes RPC. It does the RPC replication calls over the network. And that creates a tar file. And then using the tar file, we give it to the backup restore command, and we start a new domain from scratch. And you have to sort of rejoin the things again, one by one. And that's roughly how it works. So we've learned a few things in the time that we've actually built this. So that I don't really think it actually replaced the original Samba backup tools that it purported, you know, to replace, because like our tools weren't actually finished at that point. We can't restore to the same DC name. We can't restore to the same install location. So it's not really a way of just copying a DC and putting it back. And for people who, you know, deployed, or for people who clearly understood the process of what things they needed to do, or whether, or in cases where they didn't necessarily need everything up to date, they don't care that much. I think the tool that we'd sort of written hadn't quite gotten to the point where we could just replace it, but for people who do sort of redeploy using automated scripts and things like that, it was actually, the right sort of way to do these sorts of things. And for some people, it worked, or it would work quite well. So and so some of this is a question of how to sort of back up a domain versus backing up a domain controller. I think Windows has its own ideas of how that should be, but I think it's still a more difficult question than it seems to be. And so one of the other things that we actually introduced was domain renames, so we can create test environments and lab domains without passwords and secrets. And it works in basically the same sort of way, except it only works online. And basically, when it receives the replication data from the original network, it changes the top-level object in the LLAP tree and basically renames everything from that, and it all just seems to work at that point. So using that, you can see the completely new domain and then create a test network using the same process, and have something to play around with that doesn't interfere with your existing network. You don't have to deal with firewalling issues. You just have to. It's a good way to experiment with load and load testing. So one of the things is that just because you get rid of explicit secrets, it doesn't actually make it anonymized or secret-free. So you can't just distribute it still. So we've still got old DNS records in the domain, which may or may not be useful. And rebuilding the information in regards to how the network was constructed, it's there's still a whole job in of itself to do that. And maybe there's more we can do there in terms of trying to help people there. Or I think there's more that needs to be examined there, and trying to figure out how we actually build things reproducibly, because we've actually run into a lot of those issues ourselves. So the use of this in production, I don't know if we can recommend that. If you just want to, if you suddenly decide that your domain wants to be completely different, I don't know if this tool is necessarily right for you, but it could work, is what I'll say. And so one of the interesting things that we got out of this sort of backup tool was that we could start up test environments in our own test infrastructure using backups. And it's made testing much easier, upgrade testing much easier, testing under different conditions. And it made it much easier to have a clean domain controller every single time, because we were just backing up and restoring from it. So one of the other interesting things that we investigated in regards to this was Linux namespaces. So we have this project called Socket Wrapper, which sort of helps us to isolate the network so that we can run multiple Samba instances at the same time. But one of the things is that we can't actually do proper performance testing and things like that under it. And we actually, have a noticeable performance hit. And so what we did was we implemented the same sort of fakery of Socket Wrapper using namespaces, leaving it to the kernel and everything like that. And we actually got it to mostly work. We could make a test environment from a backup in our test environment that could communicate with external virtual machines and a Windows domain controller. So our current test infrastructure relies on a lot of this sort of fakery, and getting rid of it could requires a lot of work. And so there's more we could do here to try to eliminate some of the fakery and things like that. But it's still a work in progress. So one other part of the story is the GPO import and export. So it's a new way of copying over sysvol that functions across domains. So it exports a set of GPOs from the sysvol to XML and XML entities, so that you can change them as you migrate over to a different domain. And it sort of fits in with the domain rename, where if you have a backup and then a backup and then you restore it into a sort of renamed environment, you can also back up the GPOs and then restore them into there and have everything still just work. And so this is the group policy management editor. Some of you are probably familiar with it. And so during this implementation, I basically clicked through the entire thing trying to figure out, where all the settings went into what different places, and it was not very fun. You start off with the Microsoft documents, the top level ones, and you find, oh, these go to these files. These seem familiar. And then you find some more files, some more formats, and they're in different directories, which don't really make any sense. Why? And then you kind of get to a more complete set of all the documents that talk about this registry stuff and all the extensions and all the different places these go, and it's all just a mess. It really is just a mess. So I'm going to keep it short on this. I could probably talk about all the problems with GPOs all day, probably. But basically, you just go back up, restore. You can generalize it. So what you get is these XML entities, which are not that helpful, and they seem to have some long hash in them, but it's needed, I swear. And so using these entities, you can just change guest to administrator so that, guest in this domain is administrator in this domain because you clearly want that. And you can restore the GPOs with all those things mapped. The tool isn't quite complete, but it can do the basic things reasonably well, and probably better than Microsoft does, because they also have a similar tool, but it doesn't even read any of the binary files at all. It just doesn't care. Yeah, so over this last year, we've been doing a lot of automation. We've been trying to make our traffic runner more reproducible, trying to figure out, where are our problems actually, and actually have proof to show that, those are really our problems. And so we started off with virtual machines, and then, we moved to the cloud, and sometimes it's still a bit slower. And we started off with OpenStack heap templates, which weren't very good, bash scripts. Now we're sort of settled on Ansible, but it still has its problems. But at least we have sort of like modules and things like that we can reuse for different AD environments. And this actually led to a lot of upstream automation work for packages and things like that. Hopefully making sure that Samba works across different distributions and things like that has been made much easier because we've done this work. I think Andrew's going to be talking a little bit about this, but so just some things that we can build. We can build a 3DC environment or something like that. We can build something with an RDC. We can we can seed an AD domain from a backup in the cloud. So we have a backup, and then we build an environment in the cloud purely from the backup. And so this is 100,000 users or more. We can do machines and things like that. But there's still some more things that I think we could do. Make a GUI to write YAML files and things like that. We could be backed by Docker, Vagrant, and other things. And it's still not quite clear how we integrate some of this infrastructure with our existing test system, whether or not they should actually talk to each other, or whether or not we should just be switching over some tests to this kind of infrastructure. And it'd be quite interesting to get this running against Windows quite regularly. So yeah, there's some code available. It's probably mostly only useful for development, but it's probably some good examples if people want to set up some things. I don't know if there's trusts there, but we do have some set up for trusts and things like that, which took a long time for us to figure out and things like that. So there are probably some examples for some people. So we actually so we decided to put this all together. We have our automation, we have our backup domain network booted into our OpenStack cloud, and we're going to try to run our traffic runner against this all and make it all just work. Have a whole long pipeline of figuring out how our performance changes over time. And so we tried this, and we got it stuck replicating forever as soon as we tried to get the network up. So after joining a new domain controller to a restored domain, ongoing replication would just never end, which seemed weird since the join only took 30 minutes. So in theory, it should only take maybe 30 minutes, maybe an hour, maybe 2 hours, but no, it just kept going on. It just kept going on and on and on. And so we tried to use our existing tools to analyze some of these things. So we tried to use the perf graphs. The Linux perf graphs, the Brendan Gregg's flame graphs and things like that. But I think over the last year we've sort of struggled to try to use them because they haven't quite identified the things that are actually hurting us. That's not an example of Samba, by the way. So one of the things that I've been using has been Cool Grind, which has been quite helpful for giving a slightly different perspective of some of the performance things. So it simulates the caches and things like that, but it's still only single sort of process. And some of the times when it looks at simulating the caches, it doesn't actually predict very well when a cache load and things like that will actually take no time. So cases where a modern CPU manages to load some adjacent memory, sometimes Cool Grind doesn't see that, and so it doesn't quite match up to real-world performance either. But it does give a slightly different view, and it has been helpful for trying to identify more memory bottlenecks than some of the CPU's flame graphs. And so mostly what I ended up doing was just print debugging. It always works. Top, attaching to PIDs, perf top seemed to work slightly better than just perf on its own. A lot of trial and error, changing the code, a lot of timestamps, just introducing things, trying to add up how long different things take up, and it was honestly just a lot of luck. Like it is just a lot of luck. So it turns out there was actually a bug in the backup code, but it did find real-world performance issues. It seems that replication seems to re-trigger over and over again. It seems to re-trigger once right now, despite having just joined. And I don't know if we can do anything about that, but it would be nice if we could. So one of the things I learned was that accidentally doing the wrong thing means running out of memory very quickly with a large database. So in the case where you have a domain set up, there's no data in it, and you just add users to it slowly, it all just mostly works, generally speaking. But if you have a fully fledged domain with all the users and then try to join something into it, no, that's completely different. It's not the same problem. It's completely different code paths. It's really not the same thing. And so one of the things is we found that LMDB behaves completely different than our other backend because of the copy on write behavior. And what that meant is we had to batch certain operations and things like that because of this piecemeal growth sort of problem. You actually needed to sort of break things up into different chunks and things like that. Really, we really just had to learn the different semantics between LMDB and TDB. So some other interesting problems that we found while looking at performance was reindexing. So it was an example of an operation where we'd never really spotted it before. Like when we looked at a CPU graph, for instance, for reindexing, the bit which cost us was only maybe 30 or 40%, but when we fixed it, it was much bigger than that. And so there was a sort of misleading. There were misleading hints about what was actually bad in this operation, and it's been showing us that really our tools, they just haven't been working for us in the last little while. We've improved a lot of things which hurt us quite obviously, but now they're not quite so obvious. And so here are some reindexing timings. So basically, we didn't have a large enough hash size for our database or an intermediary database. And what it meant was that something that took 15 minutes really should only take 40 seconds, which is a 20 times improvement. And it was just one line of code. And it was surprising that we couldn't see it. Like, we'd looked at this code quite often. We'd seen this in it even appear in join and things like this, but it didn't look this bad. So really, I think it surprised us how different our view of what was actually bad was compared to what was really the cause. So we've been doing some more performance runs on sort of 50,000 user DC in our worst case, which is generally with a lot of links. And instead of targeting sort of the maximum operations, I sort of set it something more conservative. And in 4.9, it's not that great. A lot of calls fail. The mean is 4 seconds for a LDAP bind. Median is half a second. 95th percentile is 16 seconds. In master, it's there's no failures. There's twice as much throughput. The median is a tenth of a second, or slightly more than that, and the 95th is 2 seconds. Yeah, it's not that great. We could do better, but this is the worst case with links, and we've spent a lot of time trying to fix this stuff. Another operation that we looked at was net logon. So similar to the LDAP bind, we have failures. The max time it took to finish a net logon call was 60 seconds. And so we've reduced that in master. It's now 13 seconds or better. But at the 95th, it's not actually that bad. So at the 95th, it's like a tenth of a second, which is not too bad. So, but our traffic runner still isn't quite up to scratch. It's emulating operations that are still quite silly in some cases. We definitely need to have better samples of traffic so that we know what sort of traffic we should be, or what kinds of operations we should actually be optimizing, because mostly we've been basing our statistics and things like that from just a very small set of traces, and we'd definitely like to see more environments and examples of traffic so that we actually know how bad things are, instead of thinking that everything just works. But yeah, we should probably be trying to improve our 95th percentiles, but this is the worst case. And so there's a number of things that I think I've learned, at least, with trying to deal with a slightly more realistic 100,000 user DC. Originally when we tried running our operations, we didn't try very hard to try to emulate what a real domain might actually look like, or actually try to reproducibly run these things. One of the important things is like paging memory, at least when you have a hard disk and things like that. But even the first paging can be quite important. And in LDAP, because of the way the LDAP server operates, it allocates multiple times the database in memory, and it doesn't seem to page in the whole database necessarily as well as possible. And so sometimes it's not as performant as it could be if you had preloaded the database in a slightly different way. But in theory, lots of these things go away with SSDs, but we need to do more testing. One of the other things I learned was that loading into caches from memory can be extremely costly, which has influenced some of our database binary storage formats for 4.11. Basically, what we've done is that we've separated the data that we store for each individual LDAP record away from the offsets into that data, so that if we don't have to look at any parts of the data, we just mostly just load the metadata first, and then if there's a whole bunch of data later, on in the record, we don't actually look at it until we need to actually read it. And that actually makes a lot of the performance much better, which I showed in the previous slides. And it really showed me that outlet bind with 50,000 users in a single group, and you try to bind to a user in that group, it doesn't work. It really doesn't work. It will take like 5 or 10 seconds on average, or like the normal case is that bad. But now it's much better. It's much closer to a user who is part of a group which isn't very large. But still, we should be trying to work at the 95th percentiles and trying to reduce some of those max times, which I think will require looking at more about how we manage our connections, or how we manage memory a little better, try to reduce our allocations, and try to figure out how to make the data flow from the database to the network in a much more sensible way. The last thing, or one of the last things on this page, I think, is DNS. That we didn't realize how bad it was until we really looked at it. I think our friends from Turkey would tell you a bit more about that. But yeah, like what we found was that the bind9 DLZ is just terrible. We haven't really seen a compelling reason to use it, except the fact that it still supports zone transfers, I think. Actually, a lot of our performance in terms of pure operations per second relies a lot upon DNS, and that even just switching the bind9 backend to the internal DNS, you gain somewhere between 30 and 50% performance or something like that. Which is interesting, because you wouldn't see that kind of thing in a CPU flame graph and things like that. You don't see where things are waiting necessarily for other things. And so if we can improve some of our DNS performance, we can probably improve general performance. Yeah, I think there's definitely a lot of things that we have to be looking at in terms of DNS. But yeah, I was surprised at how much how okay the internal DNS server is compared to, compared to the bind9 DLZ, and that was kind of surprising to me. So final takeaways: real machines, yeah, they matter. So we've been doing a lot of fakery in terms of our test environments and things like that. We've been coming up with very, very synthetic benchmarks. So the original ones for search and for modifiers and things like that, actually, I don't know if they impact a lot of users necessarily. So a lot of our traffic is, DNS, LDAP, bind, and net logon calls to authenticate users. And really, we probably should be focusing on those. So in trying to look at different ways to remove the fakery, we've been looking at namespaces. Maybe we could try Docker in some cases. We've been using more VMs, but bare metal, modern hardware is probably where we should be really trying to benchmark at. So the other thing, second takeaway, was that measuring sequential operation isn't really helping. Like a lot of our tools, they only look at sequential operation. They only look at single process. Samba is a giant multi-process beast that interacts with itself in very strange ways. We use memory, we use very large M maps and things like that, which interact in ways that I don't think many other projects experience so much. And we are multi-process rather than multi-threaded, and so a lot of the tools that other people might use, they don't really help with trying to analyze what some of our problems are. And so I'm looking for new tools. If anyone has any suggestions, that'd be quite nice. So third takeaway is that yeah, we've been trying to repeat the traffic runs. it'd be nice if people external from us could try to figure out how to run this. It's not easy to run this, but it'd be nice if someone could try. And having more representative traffic would be good. So just one other interesting thing was, it's surprising how much reducing allocation helps in the multi-process case, as well as other memory manipulations. So when you look at it sequentially, or you look at it when it's not under load, it doesn't look like it would improve that much. And it does when you actually remove it out of it. And it's not entirely clear why. And I think there's other things like this that we need to be looking at in order to try to improve the multi-process performance significantly. But yeah, we definitely need more tools to help us. And I think that's pretty much it. So questions? Yes, Andrew?
So you talk about needing extra tools and backups to, particularly for the very large DC. I wondered whether you could share with the audience quite how long it took to build a 100,000 user DC before we started using the backup technology.
Well, I don't think we ever did it before we used the backup stuff, right? But so when we create a backup, it's pretty much overnight right now. Like it takes like 12 hours to, there's definitely things we could do to improve it. But in terms of just operation one after another, adding those users, it takes like 12 hours or something like that. But it's not just users in this case. So 100,000 users is actually like 300,000 or 400,000 objects. Yeah. Yeah, I mean, I didn't. I think I needed to defer to someone else on that. I don't know exactly how that plays with everything. I think we'd have to think about it. I think Andrew would probably be a better person to ask on that sort of things. But
I mean, the same answer applies if you asked a MySQL developer. What would they say? They say you have to run the freeze at the MySQL level before you do your file system. So, and so the same applies to us. You would have to take out all the locks to make sure that you actually weren't halfway through a write operation, because although we've got barriers and bits and pieces, you don't want to be halfway through a transaction right when you're taking a snapshot, and then it might operate all properly, but
it probably most of the time would be okay, except when you actually needed the backup, right?
But the important bit is that, unlike our old scripts, so a file system snapshot would be like our old scripts if they happened to lock the database correctly. It wouldn't do an authoritative restore. So part of the purpose, if you're doing a backup, you're most likely going back in time. You need to make sure that there's no way that there's another DC that's ahead of you, because it's still alive. So the tooling is specifically designed to try and reduce the chances of errors. If you look at the Windows documentation for doing restores, they give you a whole page of things you've got to do in order to set your network up to have this occur properly. We wanted that to be just the default way it worked, rather than you found the obscure document, because when people are up at 2 a.m. trying to restore their network, they don't tend to do very well at finding and correctly following the obscure document.
So in Windows, there's this thing called clonable domain controllers, which does use snapshots or something like that, but it's quite convoluted.
Two questions maybe at this point. One follow-up then for Andrew. First of all, can you explain what the issue is with restoring the backup back to the original Samba location?
Mostly it's just the tool wasn't designed to do that. It just the work just needs to be done. Any help in that would be helpful. I think it's like I think people on the list have been talking about it. It's like it's annoying. It is annoying. So there's nothing blocking it. Mostly, I think it's just some hours need to be spent properly to actually look at that. And
okay, but this is where we're heading then, basically. If I understand you right. Okay.
Hopefully, yeah.
because that's going to make it a lot easier, obviously, with systemd and all the units already in place. Otherwise you have to rewrite them too, etc., every time you do a restore from a backup. My follow-up about this snapshot question as well is like you said that Samba DC might have certain work in progress that it is not finished by the time, for example, that I do a snapshot. And I was always wondering about that. How do I get visibility on what's not finished on a Samba DC? Does it finish if I stop the server?
If you totally stop Samba, then there's nothing going on. But otherwise, otherwise any thought that nothing's going on is late information. So if you stop Samba, you've stopped Samba. Great, you're in control. But if you haven't, even if you went and checked, is there anything going on at the moment? By the time you're doing your backup, unless you're holding the locks, something's going on. You can't prove that something hasn't started happening. It's a live database. Yeah, so you just need to operate it with the same care that you'd operate your MySQL or your Postgres in terms of using the correct procedures for backing up and things. As to a little bit of the current design comes from, we sort of assumed that if a restore was occurring, that you would create a separate virtual machine. You do your restore onto that, and then you would rebuild your production network using the normal production tools that you have, using your Puppet, your Ansible, and those things, and just use that first DC as a seed, and then the manually created DC would be destroyed. That's what we imagined. We targeted towards customers that were at that level of operation. The feedback from the list is from customers at a much lower level of sophistication who would just like to put it back where it was, thank you. And so if someone comes to us with enough budget to handle that or can do the patches and test themselves, then that would be a reasonable direction to take. So it's just the tool just got aimed at a very different grade, sophistication of customer to where a lot of Samba users are at, and we hear that from the feedback. So that's just to try and explain a little bit of how we got into not quite meeting the needs of what are the larger number of users. So that I hope that clarifies a little bit about the weirdness in these backup toolings.
Anything else? Okay.
Yeah, thanks for explaining that the restore tool is still in progress, a work in progress. I was experimenting just on Monday with it, and I was curious because it required the specification of a different server name, so it was of no use for my case. I had to swing migrate back and forth to.
The code's a bit annoying.
Yeah,
Internally, we will need to do a two-step dance because of we can't have zero domain controllers, so we can't delete the one that we just had.
Yeah, it was just. I was just experimenting with it as a workaround for a re-indexing issue. By the way, re-indexing, the numbers you were showing, were they with an LMDB backend or with a TDB backend?
It doesn't matter.
It doesn't matter. Okay.
It's an intermediary layer during a transaction and things like that. Yeah.
Okay, thanks.
Yep.
Okay. Any last questions? Because we're kind of out of time. No? Okay. All right.